Imagine the entire universe squeezed into a space smaller than an atom. That's how the Big Bang Theory begins. This tiny point was incredibly hot and dense. Then, about 13.8 billion years ago, something amazing happened. This tiny point began to expand rapidly. This expansion was incredibly powerful. We call this moment the Big Bang. It wasn't an explosion like dynamite, though. Instead, it was space itself stretching and growing. The Big Bang Theory is our best explanation for how the universe began. It tells the story of how everything we see around us came to be. From that tiny point, the universe has been expanding and changing ever since. As the universe expanded, it also cooled down. Think about how steam cools as it spreads out. The early universe was like a giant cosmic pressure cooker. As it expanded, the energy within it spread out. This caused the universe's temperature to drop. This cooling was crucial for the formation of everything we see today. As the universe cooled, tiny particles began to form. These particles eventually combined to create atoms. Atoms are the building blocks of everything: you, me, planets, and stars. Over millions of years, gravity started to shape the universe. Gravity is a force that pulls things together. It pulled atoms together into giant clouds of gas and dust. These clouds became so massive that they collapsed under their own gravity. This collapse ignited nuclear reactions, giving birth to the first stars. Stars began to cluster together, forming galaxies. The universe was no longer a uniform soup of atoms. It was now a vast and complex tapestry of stars, galaxies, and swirling clouds of gas and dust. The Big Bang Theory isn't just a guess. Scientists have found evidence to support it. One piece of evidence is the redshift of galaxies. As light travels through the expanding universe, it gets stretched out. This stretching makes the light appear redder. By observing this redshift, astronomers can tell that the universe is expanding. Another piece of evidence is something called the cosmic microwave background radiation. This is a faint afterglow of the Big Bang. It's like the heat left over from the universe's fiery birth. These observations, along with others, provide strong support for the Big Bang Theory. They help us understand the grand story of our universe, from its explosive beginning to its ever-evolving present.